Right. So in this video, we are going to see the single line diagram of substations. Basically, first of all, we have to understand what is substation and what are the different type of substations are available. So basically, if you see if you have seen the previous lecture, like there I have discussed about single line diagram, where I have discussed about generation, transmission, and distributions. So there we have seen like um you have this transformers like step up or step down transformers. Here, these transformers are basically located in a substation, you can say. And in substation, you will be having this transformer. Not only transformer, there are some other devices also, some switchgear devices and some other measuring instruments and all will be there in substation. So basically, this is also you can say this transformer will be located in a substation. This transformer will be located in another substation. So these are the you can say substations. Okay, and these are the transformer substations. Like if I if I say what is substation, substation is nothing but a place where we do some changes. Maybe we want to change some voltage level. So that voltage level change can be done by transformer substation. Then there can be another substation where we can transform or we can change the AC to DC. Like we have this HVDC link also. So we can transform that AC signal to DC signal and the transformation will take place in a substation with the help of rectifier and all. So there can be another substation for this AC to DC, DC to AC conversions. So that is something. So we can say there are substation for rectification, there are substation for inversion, and there can be several substation also to improve the power factor. And there can be other substations to change the frequencies. So there are many substations you can say, but whenever when you heard this name, so substation, the single line diagram of a substation, basically you can implicitly understood like that substation is basically transformer substation until unless they have mentioned something. Okay, so here in this video we are going to discuss about the transformer substation. Although there are many types of substation, but majority of the time if you are asked to draw the single line diagram of a substation, that means you are like the interviewer is expecting a substation diagram for us for like transformer substation. Okay, so we will see what are the equipments what are the elements are there in transformer substations. So the first element or first equipment you can say there is a bus bar. What is bus bar? If, I hope you guys have studied the network theory. In network theory, we have something called node. So you can say in power system, whatever we call node in network theory, the same thing can be represented as a bus bar in a power system. In power system terminology, we use the node as a bus bar, and it is basically it is a midpoint of many branches. So and it is made up of copper or aluminum bars and all. And the second is isolator. Isolator is it is a kind of it is a switch gear, and it operates at no load, and it uses along with circuit breaker. We will see how it operates. And now the third one is a circuit breaker. It is also a switch gear, which is nothing but a mechanical switch that trip the lines, or if there is an abnormality in the system, and it gets signal from relay. And there is like power transformers, you can say power transformers, it is the device that is the main you can say heart of a substation. So it basically transform the voltage like high voltage to low voltage or low voltage to high voltage, like that. So it transform the voltage level, or change the voltage level. Now come to the instrument transformers. Instrument transformers are two types. There is one something called current transformer. There is one more, something called potential transformer. Current transformer is basically it is used to measure the current, and then the potential transformer is used to measure the voltage. Basically in high power application or transmission levels, the voltage and the currents are huge. Maybe the current that are flowing in a particular line is in the range of kiloampere, or the voltage that you have line to neutral voltage, it is maybe in the range of kilovolt, but the measuring instrument cannot measure such high voltage or high level currents. So we have to step down those levels, and we can use the measuring instrument to measure the those voltage and currents. Okay, and this CT and PT inputs are also required for relay, because the relay is the main, we can say, brain of a circuit breaker. So depending on the voltage or current signals, if there is any abnormality, the relay sends the trip signal to circuit breaker and trips. Basically, if I talk about from circuit breaker point of view, uh, a circuit breaker operates depending on the electrical quantity such as voltage, current, frequency, phase angle, impedance. Like these are the quantity, electrical quantities. Based on these quantities, if there is any abnormality in these quantities, then my relay will send a trip signal to circuit breaker and it will trip. So this is how the transformer, the circuit breaker, and this instrument transformers and the relay and all operate. And the last is the lightning arresters. Lightning arresters, basically there will be lightnings, and they are basically comes under over voltage transient, you can say. So this over voltage transients are kind of traveling in natures and all, so and they are will be high magnitude in nature. And this lighting arresters, actually, you can say, offer a less impedance if there is any high voltage transients or over voltage transient or lightning. So if I talk about that, the VI characteristics of lightning arrestor, it is a non-linear characteristics. Like at normal voltage, it is a linear, but at very high voltage, it offers a non-linear characteristics. The resistance will be very minimum. So it is linear, but at high voltage, it will be non-linear in nature. So let's say this is your voltage and this is your current. So the VI characteristics of lightning arrestor is non-linear. Let's say up to this region, it will be linear. The resistance will be fixed, but till beyond that, it is a non-linear characteristics, and current will be current that is flowing through the area lighting arrestor is also maximum, or like not maximum, it is very high, you can say. So at very high voltage, this lightning arrestor offers very less resistance, such that that charge that are associated with the lightnings or over voltage and all, that can go to the ground. So it is a kind of it is for the safety purpose, and these lightning arresters are that will be installed at the initial portion of the substation. Okay, so we will see the single line diagram now. And these are the you can say in single line diagram, this is how we will be representing each of the elements. So like, this is the representation how we will be representing it. Okay, so and basically, once we say single line diagram of substation, it is not only those six elements or six equipments that are required in substation. There are several types of equipments that can be used in a substation, but on the broader level, these are the you can say these are the equipments that are required. But beyond that, there are some other equipments also that can be used. Okay, and depending on the voltage level or depending on the power, like let's say your substation is something that is converting maybe 13 kV to 765 kV, so there is a huge voltage step up. So maybe there the single line diagram of the substation will be different. Maybe you are doing something 33 kV to 11 kV step down, so maybe there the single line diagram of a substation will be different. Like the equipments may vary, substation to substation, but the thing is, the fundamental things that will be same for all of the substations, but there will be some minor changes in the various substations. So if I talk about the single line diagram of substation, so first what will be there, just if I briefly say what is substation. Substation will be, it is a place where there will be a incoming line. Okay, and there will be a outgoing line. Okay, obviously these are the three lines. Okay, and in this substation there will be some changes. In our case, we are considering only transformer substation. So there will be transformers. It is the main equipment or the heart of the substation, you can say. And so we'll see the single line diagram. So let's say you have this bus bar, bus bar, the operating voltage at bus bar will be same. It is your bus bar. Okay, and there will be incoming lines and there will be outgoing lines. Okay, so let's say you have this incoming lines. We have this incoming lines. Okay, and at the starting of the substation there will be lightning arresters. So this is your lightning arresters. Lightning arresters. Okay, now you will be having isolators. So and there will be circuit breakers, and there will be actually in circuit breaker we need the input from CT and PT also. So there will be potential transformers, and here will be CT. There will be one more isolators. I'll write all the names here. So this is your CT, this is your PT. These are the measuring instrument. The input of the, like the output of the CT and PT will be given to the measuring instruments, you can say, to measure the voltage and currents level and all. Okay, and it is your incoming line. Okay, and if incoming line has any kind of surges or over voltage like lightnings and all, so those will be go to the ground. Okay, so for the safety purpose at the initial at the start of the substation we will be having this lightning arresters. Okay, and this is my circuit breakers. Okay, and this is my isolator, and this is also isolator. Okay, this is also isolator, and this CTPT input, the CTPT output will be given to the relay, and depending on the nature of the voltage and currents, it will the relay will send the trip signal to circuit breaker, and circuit breaker will trip. So one thing that you need to know, this isolators, basically this isolator operates at no load. That means if there is any there is an issue, then the circuit breaker will operate first. That means the circuit breaker will trip the line, and after that you have to manually operate the isolators to maybe to repair the circuit breaker. So once you have the circuit breaker on the both the sides, you just you can just bring back the circuit breaker, and you can repair the circuit breaker if there is an issue. So for that purpose you have circuit breaker, the isolator on the both the side of the circuit breaker. Okay, now you have the outgoing lines. Okay, so outgoing lines, again there will be isolators, circuit breakers, again isolators. Okay, this is CT, there will be isolators, and there will be transformers. This is my outgoing lines. Actually you can also connect one more lighting arrestor here for the better safety, you can say. If there is any surges comes in the bus bar itself, it should not travel to the outgoing line. So basically this is your outgoing line. So you can have one more lightning arresters at the terminal of the uh, power transformers, you can say. And this is CT, and this circuit breaker requires the output from uh, potential transformer also. So you'll be having one more potential transformer, let's say here. So there will be another potential transformer PT and CT, and these are the isolators. So this is how there will be one out incoming line, and there will be outgoing line. So this is the basic structure of a substation. You can have multiple bus bar in a substation. You can have a single bus bar with multiple sections. There will be several scenarios, and depending on the voltage level, power levels, and all, the single line diagram may vary, but this will be the core functionality, you can say. You can see that there will be substation, there will be some earth switches and all, capacitor CVT will be there. So there are many equipments will be there, and coupling transformers and all those things will be there. But these are the essential equipments that are required in a substations. I hope it is clear. And this is my transformers. You can say this is my power transformer that will do the main job actually. Okay. Yeah. Thank you. If you have any doubt, you can ask me in the chat box. Thank you.